Mm.
Okay, you asked me about the big O question. Are you a computer science student or a mathematical student? Oh, okay, computer science, that's good. And big O is for it is a notation like that, and to define it is used to define the function, the function probability, and for its uh, asymptotic probability for the function. And you can, for example, we can do an example here and you can understand it better. So let's give a for loop here and for this I from 0 to n and do some drop here. So we define this drop here like a J function, and then we end for. So from this function, you can this complexity for this function for this part is O n. This means that because the loop it loops n times for this g function, so that the complexity, if the complexity here is O1, and then the whole part have the own complexity. So we can say that O notation it defines the function. It defines in computer science. In most time it defines the complexity of a function or a part of code, like something, yeah, something like that. So in C function, it is like this. It is O(n) like that. So O(n) is the upper bound of the function. So if a function has the complexity, that means it has a complexity less or equal than n. So we can define it as O(n). And sometimes it has some other notations for this computer science algorithm complexity. It also has this is big O, and it also has small o and the big omega to define the big omega is to define the lower bound for the function, and small o is kind of a little similar with this big O. So yeah, if you are actually in mathematical view, and the big O is more complexity. It has more, it used in more places than this. But in computer science, and we can think it simply and to use it only for most of the time, only for the algorithm complexity, and we can analyze from the algorithm to get the complexity and use the big O notation to define this. And if algorithm has a big O n, and the temporal complexity will be less or equal than n. And then sometimes you may say like O log n, and this log n is also O log n is also a time complexity for algorithm, and this is driven. This is deduced from some algorithm. So you can use some method and learn from the introduction to algorithm to test it better and then to deduce it. So yeah, is this answer your question?